Joel, come here. Give him a round of applause. Yeah, Joel and me, we have also some history together. We actually started together working in the same company called Consensus a long time ago. At that time, we were still working on prediction markets, and Joel was working on Uport, which was also a project was very ahead of its time, building smart contract-based accounts with recovery and basically any kind of feature. Wallet Connect was kind of all built into one product. It was great. But anyway, so
it was.
It was great, yes. But at that time there were no users, generally in the ecosystem. But yeah, now after quite some pivot, Joe is working on Ceramic, which is a super interesting project. And yeah, I'm excited to learn more about composable data on Ceramic today. Thank you, Joel.
Awesome. Thank you, Stefan. So today I'm going to be talking a little bit about Ceramic, giving you a general overview of our protocol and sort of the tooling we're building on top to really enable developers in the ecosystem. So let's first talk about sort of the data that you have already and that you have already across multiple different blockchains. If you've been in this sort of the Web3 crypto ecosystem for a while, you probably used Ethereum, you probably used Bitcoin and a bunch of other blockchains. You end up having like multiple different wallets across all these different blockchains. Your data also lives across all these different contexts. And inside of this data on all these different blockchains, you have a lot of like a reputational and social context that is really valuable. But you don't really have a way to like bring that with you as you move across these different ecosystems. And of course, like we know that Web3 developers love reusability. We love to just like take a component that someone's built and reuse that in our application and just like compose on each other's work. But the thing that's like hasn't really been easy to use and been there is this shared metadata layer where we can like connect all these things and just like bring things with us. In the financial sort of blockchain ecosystem, we sort of have beginning of like bridges in some places that work sort of well. Sometimes not very well, but we don't really have that for data, and it's like ways of bringing reputation data across different ecosystems. And really what we want is something like a composable identity system where you can use like link together your different wallets across like multiple different blockchain ecosystems. And you want to be able to build sort of a web of trust between you and your sort of peers that you're interacting with. And actually, like Web of Trust is a pretty old concept. Back in the days we're building out the PGP sort of standards, we actually started to build a Web of Trust. But the problem with Web of Trust is that you need these sort of very weird ceremonies for building trust. You need to go to like a crypto party and then go and sign each other's keys, which is like sort of this weird social interactions that most people are never going to do. They're not comfortable with that. So we can't like naturally use that to build sort of like a global reputation, sort of web of trust system where we can sort of deduce trust based on your friend's trust. But I think like if we can have more interactions be verifiable, we can actually move in that direction. And if instead of having to do special interactions to verify each other's sort of trustworthiness, if we can have all of our interactions that we do when we engage online be verifiable in the same way like a blockchain transaction is verifiable, we can start to have like identity and reputation be more of like an emergent phenomena based on these interactions. And in order to do this, we can't, of course, like scale by putting everything on chain. Blockchains have a hard time like reaching the sort of scalability that you have at like social networks and like really large applications today. So we need some way to have data off-chain, but in a verifiable way. And we also, of course, like don't want to lock ourselves into a global reputation system, and that's why it's important that we have this composability, and the reputation becomes like contextual. So I think that the paradigm that we should really strive for in Web3 is this concept of a self-certifying applications and self-certifying data, where users bring their data to applications, and the fact that you can just look at this data that the user have created, and you can see the authenticity that this data actually comes from the user. And you can't, because like in sort of Web 2 world, we have this problem where whoever's running the backend can actually change the data or claim that the data was different or something didn't happen. And this is a real problem in DAOs and other sort of DeFi applications that have their core components decentralized on-chain, but everything else lives on like a governance form that like one guy controls or something like this. And in theory, like if something goes bad, that person can just like censor someone or change what someone said, like, and which is also true on like Web2 platforms. And so with user-generated authority, having the user actually sign all the actions that they take enables us to build much more trust in our digital interactions. And once we have this sort of data structures that are signed by users, we can also start to synchronize this data in a peer-to-peer fashion. All right, so all of the sort of things that I was talking about, this is sort of what Ceramic enables. So Ceramic is a decentralized composable data network. And I'm going to get into what that means. But in essence, it allows us to share data across applications and let developers compose on data that other developers have created. So we have sort of this shared network effect. So Ceramic is designed to be scalable in a way which blockchains are not. And the reason we can scale much further is that we don't rely on like a strong consistency guarantee that blockchains have. In blockchains, everyone needs to agree on like what the next state is in order for us to prevent double spends. But in a sort of pure data system where you only care about like the integrity of data, not necessarily like complete ordering of all transactions that happen in the entire network, we can sort of loosen some constraints and gain a lot of scalability. And we can sort of also verify updates locally before they go out to the rest of the network. We can make the data mutable. So if you've ever used networks like IPFS or Storj or Filecoin, like those are great for storing data, but generally you store files, and you don't have like great options for mutability. And so this is something that we've focused a lot on with Ceramic. We of course want to make it flexible so you can store different sorts of data. And we focused a bunch on interoperability as well. So the sort of account system we have in Ceramic is based on decentralized identifiers. And this actually enables us to have many different blockchain wallets can interact with the data, and you can write data to the system. So in the core data structure of Ceramic, the sort of core properties that we care a lot about is having tamper-proof timestamps, and we get this by sort of anchoring updates into the blockchain to get this sort of timestamping of like when events took place. Data in Ceramic is written as a hash-linked event log, and I'll go into that in the next slide a little bit more. And of course, we use peer-to-peer applications. So when you spin up an instance of Ceramic, you can replicate data from the network without having to connect to like any particular node. And finally, one really important aspect that I sort of touched on already is this concept of having the data be attributable. So you can look at the data and see who actually wrote this data and verify that automatically. So I'm going to just like briefly explain sort of the core data structure of Ceramic, which is a self-sovereign data stream. And so here you can see sort of this event log. We have a Genesis event that's sort of like the creation event of a new event stream. Then we have these timestamps, which essentially is including the hash of the previous event into the blockchain. And then we have these data events, which basically are signed events that are published to either modify some state or publish some new data that's associated with this event stream. And then these sort of events just like continue. So we have the stream of signed events. They're timestamped. Each event stream has an immutable stream ID, and that stream ID is based on the hash of the initial Genesis event. And of course, like this, everything is signed with this DID, as I mentioned. Now, when a node uses, if you spin up a ceramic node, the way it uses this data structure is that it connects to the network, it has a stream ID, it asks other nodes in the network, like, hey, what are the latest events that I'm not aware of? And then it can synchronize these events and verify them locally and potentially run some computation on top of these events. And the timestamps, as I mentioned, are guaranteed by the blockchain. But of course, it wouldn't be very scalable to make one blockchain transaction per event that we create. So we essentially just like have a system that allows you to batch multiple events across multiple event streams into a Merkle tree and put the root of that Merkle tree on chain. And this, of course, can work with like any vector commitment. And so how do we use these event streams for something that's meaningful? In Ceramic right now, you can use it to create just like plain JSON objects. But we've been working on a new system that we think really enables way better developer experience, and that's called ComposeDB. So ComposeDB is the first graph database that's built on Ceramic. And it basically provides with an interface that's almost pure like GraphQL. So you define your data models in GraphQL, you can make queries, and you can make mutations using GraphQL. ComposeDB is sort of like the indexing layer that indexes a bunch of Ceramic streams based on sort of which data models you care about. And then in the bottom, we have Ceramic is this event streaming protocol. So the core piece in ComposeDB is this data model. And the data model is pretty simple. It's basically a JSON schema that defines the structure of the data. And then there's just like some contextual metadata, like the name and maybe a description created by the developer to give other developers context about what this data model does and was used for. And now like different apps can, of course, like pull in data models from that already exist on the network. So as an example, right now Gitcoin has this app called Passport, which allows you to store a bunch of stamps, basically verifications of that you have like different, you have used different Twitter or Facebook or Proof of Humanity or like all these different systems to give you some like unique Sybil resistant score. And so Gitcoin is actually in the process of migrating to ComposeDB. Once they've done that, anyone can spin up a node and tell it to index Gitcoin Passport data, and then you can use this Sybil resistance score in your application for sort of whatever you want. But of course, like you can of course like build these data models for anything like commenting and so on. Oh, and one thing that's important to mention here is like the data model is created by a developer and it's immutable. So you can't sort of be rug pulled by a developer that decides to change the data model and then no longer works in your application. It's immutable. So once the data model is created, it's there. And every user that writes data to this data model writes it to their own event stream. So you can sort of like pick and choose also which subset of users you want to store the data of. So you can have like a index only a subset of users' data, or like all the users that have created data in this data model. So we think that underlying models and schemas for data can create like a new era of like open source information. We've had this notion of open source code, and that's something we all rely on a lot. But what if we can actually open source all the data that we generate when we use the internet? And we can start to build a consensus on like what are important structures for data. In the same way, we're sort of starting to build consensus around like what are important smart contracts to use. Like we need some sort of exchange, we need some sort of non-fungible token infrastructure. I think there will be similar sort of data structure that emerges in this data ecosystem. And one cool thing about these building applications in this way is that we have between us as a Web3 community, we can get a shared network effect where If first application comes along and builds an application onboard 1,000 users, and they have like a really nice profile system and some really nice like commenting feature, another application doesn't need to rebuild that and re-onboard the 100,000 users. They can use the same data models. Now they already have 100,000 users that are already onboarded into the application, and they can sort of display their information, maybe it's a blog post or something else, directly in their app. And this new app maybe onboards another 1 million users, and now the first application benefits. And I think these sort of shared network effects is how we can actually start to compete with incumbents in the Web2 ecosystem. I think some of the core things here that we can build with this technology is around sort of this aggregation of identity. I think like the use case that Gitcoin has with like the passport is interesting, but I think also as you start to build reputations by contributing to like open knowledge graphs or DAO proposals and comments, like governance discussions, you have and other sorts of like interactions you do, you can start to build a reputation based on this. And you can have like different aggregation services that looks at the combinations of different data models and sort of like builds some context. And I think it's like once like with this sort of like composability in data, there's like so much things you can do. I think also one thing that might be interesting to look at in the future is like building composable data pipelines. Where we have like big compute nodes that ingest data from a set of users or from IoT sensors that have been generated, run some computations on that, outputs that as event streams themselves, then other computation nodes can take that and sort of like build this computational pipeline like you have in sort of Web2 companies, but in an open way and have like open sourcing data in that way. All right, so I hope I gave you a generally fine overview to Ceramic. Here's some general resources, and we're also hiring. So yeah, excited to continue to build the future of Web3 together.
Yeah, thank you, Joel. I think it was a very good introduction. I have one question. You mentioned Gitcoin as being integrating Ceramic. I think recently we saw a lot of Twitter users starting exploring alternatives to Twitter. Do you see such an alternative built on Ceramic also being a good application for Ceramic? Is someone exploring this? Or what kind of, do you see generally like people that build social media alternatives exploring Ceramic?
Yeah, there are two sort of larger applications that are building social media on Ceramic. One is called Cyber Connect, and they're sort of building like a Web3 project profile system, but they want to expand that to generally social media as well. Then there's another project called Orbis. They already have a social media platform that's live and working. It's sort of similar to Twitter. And they also have built an SDK that sort of like makes it easier to just use like build social features on Ceramic, like plug it into your app, but it's like using the Orbis structure. So those are like the main examples I've seen. And a lot of people have actually started using the Orbis SDK to build like comments and things like this into their applications. So we're already starting to see some of that composability. Oh, and I also saw that the people behind Orbis built a system where you can query what's it called? ChatGPT, like the new AI chatbot, and get the results written into Ceramic in sort of like a verifiable way. So that's a little bit fun.
That's amazing. A new era for bots participating on that. That's the way how you bootstrap users nowadays. Just integrate into this AI. Great. Thanks a lot, Joel.